Okay, so what we're interested in is where point P, or the path that point P follows, as this blue radius of this large circle spans from theta is greater than or equal to 0 up to 2 pi. As it moves, that we'll acknowledge the following rule. The point P, its x-coordinate will always be directly below this point up here, which I'm going to call x1, y1. And it'll sort of like hang from there vertically as this moves around. And the y-coordinate will correspond to the place where this base of the triangle intersects the smaller circle of radius b. The question is, what is the parameterized equation for the path that P follows? Okay, so I guess the first thing you can notice is that if you compare point P to this point x1, y1, based on the rule we're supposed to follow as point P moves around this circle, we know that these x-coordinates are going to be the same. So I'm just going to focus on the big circle for a minute, the circle of radius A. And what's nice is I know how to parameterize a circle. It's always the radius times the cosine of theta plus, comma, the radius times the sine of theta. So we end up with A cosine theta, A sine of theta. And like we just mentioned a moment ago, we know that these x-coordinates are the same. So now we have the x-coordinate, our parameterization for the path of P. So we know that x of t is going to be A cosine t. Okay then, so now we're interested in y. And what we can tell is that y, this y-coordinate here, has something to do with the y-coordinate at that point. Well, luckily, that point, as I called it, I'm going to call it x2, comma y2, moves along this smaller circle, the circle of radius b. And again, we know the parameterization for that. That's going to be b cosine of theta, b sine of theta. Well, what do we know about point P? Well, we know point P's y-coordinate is exactly the y-coordinate of this point, which is y2, which we just said is b sine of theta. So now we have the y function of our parameterization, which is going to be b sine of t. Okay. Well, some of you may recognize this. If you look at this, it's actually a pretty special equation. That is an ellipse. You can verify that, or sort of confirm it, by remembering the rectangular equation for ellipse, which is x squared over a squared plus y squared over b squared equals 1. Well, if this is really, this parameterization we just found is really the parameterization of an ellipse, it can be checked by plugging into this equation and making sure that this equation holds true. So here we go. A cosine t quantity squared over a squared plus b sine t quantity squared over b squared is supposed to equal 1. And if we just square the top here, we get a squared cosine squared over t over a squared. And now you can see those a's cancel. Okay. I always get kind of happy when I see a cosine squared because I'm hoping I'm going to add it to a sine squared and get 1. Well, sure enough, that's exactly what happens. These cancel. And now you have cosine squared plus sine squared, and that equals 1. So this thing really is an ellipse.